Let's use the monotone convergence theorem. Well, here's a complicated sequence. It's a sequence that starts with its first term equal to 1, and subsequent terms, a sub n plus 1, will be defined in terms of a sub n, will be the square root of a sub n plus 2. This sequence is bounded above by 2. Well, let's see why. Let's suppose that a sub n is between 0 and 2. Then what do I know about the next term, a sub n plus 1? Well, then a sub n plus 1 must also be non-negative, and that's just because it's the square root of something. But how big can a sub n plus 1 possibly be? Well, a sub n plus 1 is the square root of a sub n, which could be as big as 2, plus 2. So a sub n plus 1 can be as big as the square root of 2 plus 2, which is equal to 2. And this is great, right? This is telling me that if I know that a particular term is stuck between 0 and 2, then the next term is also stuck between 0 and 2. And what do I know about the first term? Well, the first term is definitely between 0 and 2, right? A sub 1 is between 0 and 2. And that means that the next term must also be between 0 and 2. And that means that the next term, a sub 3, must be between 0 and 2. And that means that the next term, which is a sub 4, must be between 0 and 2. That means that the next term, which is a sub 5, must be between 0 and 2, and so on. And what this actually is telling me is that no matter what n is, a sub n is between 0 and 2. And this sequence is non-decreasing. To show that this sequence is non-decreasing, I'm going to show that a sub n is less than or equal to the next term, a sub n plus 1. And of course, I got a formula for the next term. That's just the square root of a sub n plus 2. So the question, is this true? Is a sub n less than or equal to the next term, the square root of a sub n plus 2? And since a sub n is non-negative, I can figure out when this happens just by squaring both sides. So I'm wondering, is a sub n squared less than or equal to a sub n plus 2? I'm going to subtract a sub n squared from both sides. So I'm wondering, when is negative a sub n squared plus a sub n plus 2 non-negative? Now I can factor this. This is asking, when is 0 less than or equal to, how does this factor? I've got a 2 there, so I'll write a 2, 1, 2 minus a sub n, 1 plus a sub n is how this quadratic polynomial factors. So the question is, when is this product non-negative? Well, in order for this product to be non-negative, either one of these is 0, or they're both positive, or they're both negative. It can't happen that both these terms are negative, so the only possibility is that a sub n is 2, or a sub n is minus 1, or both of these terms are positive. And that happens when a sub n is between minus 1 and 2. So the upshot of this whole argument is that as long as a sub n is between minus 1 and 2, then a sub n is less than or equal to a sub n plus 1. But I know that a sub n is between minus 1 and 2 because just a little while ago we saw that a sub n was stuck between 0 and 2. And consequently, this sequence is non-decreasing. What does that all mean? So I've got this sequence, and the terms of the sequence are between 0 and 2, and that means that the sequence is bounded. And the sequence is non-decreasing, which means the sequence is monotone. So I've got a monotone bounded sequence, and by the monotone convergence theorem, that means that the limit of the sequence exists. We can try to get some numerical evidence to guess the limit. So the first term in this sequence was just defined to be 1. To get the next term, I use this recursive definition. I'll add 2 and take the square root, and that gives me the a sub 2 term, and that's the square root of 3, which is about 1.73. Now to compute the next term, what do? Well, using this formula, I'll add 2 and then take the square root of all that. That'll give me the a sub 3 term, and that's about 1.93. Now to compute the a sub 4 term, right, it's the same sort of process. I'll add 2 and then take the square root of all that. That'll give me the a sub 4 term, and that's approximately 1.98. And if I keep on going, well, you might believe then that the limit of a sub n as n approaches infinity is in fact 2.